In this podcast, we're going to look at setting up word problems which can then be solved using the matrix methods that we are working on here on test 7. So I want to begin with an example, a very simple example of a problem with two equations and two unknowns. It's kind of a business related problem. It says a company has fixed costs of $15,000 per month. It costs the company an additional $300 to make 1 unit of its product. Now, I haven't specified here what 1 unit means. 1 unit could be one product, one item, like maybe a fancy $300 valve or something like that, or it could be multiple products, like 1 unit might be 3 dozen hats. But whatever it is, 1 unit costs $300 to make. It sells every unit that it makes, and it gets $450 per each unit that it sells. So $450 per unit revenue, $300 per unit it costs the company to make the product. How many units must it make and sell each month to reach the break-even, or what we call the equilibrium point? Part A says write a system of equations which can be used to solve this problem. Okay, clearly this problem is about costs and it's about revenues. So what we're going to do is we're going to write a cost equation and a revenue equation. And I'm going to say that the cost is composed of two different points that are both mentioned in the problem. First off, you have the fixed costs of $15,000. Now, fixed costs are just costs that you incur whether you make any units or not. So the rent on your building would be a fixed cost. The landlord doesn't care what you're doing in that building, but he wants his rent. So whether you make products or not, it's going to cost you $15,000 a month. And there are other fixed costs like salaries of office workers and things like that that don't directly relate to how many units you make. But then you also have what are called the variable costs, and the variable costs come from the number of units you make. And I was a little bit remiss here. The very first thing you want to do in a situation like that is clearly define your variable. And to do that, you normally go to what the question asks. And up here in the third line, it says, how many units must it make and sell each month? So I think the first thing I'd actually do, even before I start the cost equation, is I would say, let X be the number of units made and sold each month. That's what they want us to find. That's what we're going to let X be. When we find X, we're through. Now, the next thing it wants us to do is write our system of equations. So again, I'm going to start with the cost equation. Cost, again, will come in two parts: the fixed parts, which we've already discussed, and a variable part which depends upon X, the number of units we make. If I make 1 unit, it's going to cost me 300. If I make 2 units, it's going to cost me 300 times 2. 3 units would be 300 times 3, etc. So that if I make X units in a month, it would cost me 300 times X. For your revenue, similarly, well, in revenue, in this particular problem, there's no fixed revenue, but you could have fixed revenue. If you're a gym and each person who goes to the gym pays you an automatic $50 a month, that's fixed revenue, so that would make sense, but we don't have it in this problem. Here, all our revenue comes from products sold. So if I sell 1 unit of product, that's $450. 2 units of products, $450 times 2. So X units of product, $450 times X. And there's our revenue and cost equations. Now the next thing says put this in the form of an augmented matrix. Set this up in a way that you could use Gaussian elimination to solve the problem. Well, notice I said it was going to be 2 equations with 2 unknowns, but I'm showing 3 unknowns. Well, I'm not really having 3 unknowns, because to reach equilibrium, which our problem says, we have to have that the cost and revenue are the same. So I could just rename the cost and rename the revenue Y, because they're both the same thing. Then my system would read Y equals 15,000 plus 300X, and Y equals 450X But if I'm going to get this in the form of an augmented matrix, I want to start with x, then go to y, then go to my constant. So here's how I could do that. I like to have positive coefficients on x if I can, so I'd leave my x on that side. And the first thing that would go in would be the 300 from the 300x. In other words, I'm going to set them up this way. I'm going to take my first equation and make it look like this. Leave the 300x alone. Bring the y over to the same side so it'll become a minus y, and move the 15,000 to the other side so it'll become negative 15,000. Then do the same with the other one. Leave the x where it is, so 450x, and bring the y to that same side, so I'll say minus y, and then what'll be left over here is 0, so I'll say equals 0. And so now it's pretty easy to see how to put that into augmented matrix form. Here's your matrix. Oh, this is supposed to be 450x, not 45x. First, you pick off your matrix of coefficients, which are the numbers that multiply x and y. So x is multiplied by 300, y is multiplied by negative 1 understood. In the second equation, x is multiplied by 450, y again by negative 1 understood. You put in your row of dots, and you put your constants, negative 15,000 and 0. And now you could use your Gaussian elimination method to solve for your x and your y. X is here what you're really looking for. Let's go on to another example. In this example, we're going to end up with a system of 3 equations and 3 unknowns. Let me move my page up a little bit. That went a little bit too far. Just wanted to move it up slightly. This is going to result in a system of 3 equations and 3 unknowns. It says write a system of equations which can be used to find the coefficients a, b, and c. So I want my unknowns in my system of equations to be a, b, and c because that's what I'm looking for. And they're going to be the coefficients of the function y equals ax squared plus bx plus c. So what we're saying here is if a is 1 and b is 2 and c is 3, our function is going to be y equals x squared plus 2x plus 3. A is 1, b is 2, c is 3. Well, it wants us to find a, b, and c so that we get a quadratic function. Now recall that a quadratic function is another word for parabola. A parabola that goes through the 3 points, negative 1, 5, 1, 3, and 2, 5. And when we say that the parabola goes through the point, negative 1, 5, what we're really saying there is f of negative 1 is equal to 5, where negative 1 is your x and 5 is your y, just like in that point. Well, let's see. If 5 is my y, then I could put 5 here for the y. So I'll start off that way, 5. And then over here for the x, if x is negative 1, I'll just go to my formula, ax squared plus bx plus c, and I'll put in negative 1 for x. So a x squared plus b x plus c. Now, you go ahead and do that for the other 2 points and write them right underneath this equation, and I'll just stop the video a second, and when I restart it, mine will be all done, and see if yours agrees with mine. Okay, we're back. Here are my other 2 equations. 3 equals a times 1 squared plus b times 1 plus c, and 5 equals a times 2 squared plus b times 2 plus c. Now if I just go ahead and work out the arithmetic part, I get 5 equals a, because negative 1 squared is just 1, minus b, negative 1 times b is minus b, plus c. I get 3 is equal to a plus b plus c, and from my last equation written over here on the right, I get 5 is equal to a times 4 plus b times 2 plus c. Now if I want this in the form of an augmented matrix, I want my a, b's, and c's on the left lined up in alphabetical order, and I want my dotted line at the end with my constants 5, 3, and negative 5 on the other side. So I'm going to rearrange them here. And remember, I only want the coefficients. I don't want to put here A's, B's, and C's. I want to put the coefficients of A, B, and C. So for the first equation, it's 1A minus 1B plus 1C, and then here's my equal sign, equals 5. And for my second equation, 1A plus 1B plus 1C is equal to 3. And for my third equation, 4A plus 2B plus 1C equals 5 again. And there is my augmented matrix. Now if I solve that augmented matrix, that's going to tell me what A, B, and C are. And once you know what A, B, and C are, you just plug them into that formula. And I can tell you what they are. I'll just what you get if you work all this out is that you will get a final answer: A equals 1, B equals negative 1, and C equals 3. And so what that would mean, you have now found the coefficients. Now if I ask you what is the quadratic function that goes through those 2 points, then you would write out the formula. You could say f of x or y, that doesn't matter which one you use, is equal to, instead of ax squared, you just go 1x squared. Instead of plus bx, you'd go minus x. And then for plus c, you'd go c equals 3, so you'd go plus 3. So that is how you go about setting up a system of equations, and that is how you use take that system of equations you set up and get it into augmented matrix form, so you can then use matrix method to solve the system.